Let's talk about the Haken Audio Control Voltage Converter and how you connect that up and use it with your Osmose. Now, you may have an older version of this if you also have a Continuum. The newer version is low profile, has an external power supply as opposed to the older one which had an internal supply. The low profile model also has a TRS input that's used to connect up a slim Continuum or a Continuum Mini, in addition to the DIN port that the old one had as well. Well, let's look at our diagram now. You're going to want to power by plugging in the power supply. Connect up the output of the Osmose with a fully populated MIDI DIN cable to the I2C DIN input, fully populated cable, because the CVC uses the unused MIDI pins for the I2C connection to communicate from the Osmose to the CVC. If you want, you can connect the through from the CVC to some other external instrument. Perhaps you want to control both the CVC and an external instrument over the DIN port, and optionally send that back to the Osmose if you want to play the Osmose over DIN while you're using the CVC. But most of the time I think everyone's going to be using the USB ports of the Osmose for playing it, and just the out port from the Osmose, the MIDI DIN out, to connect up to the CVC. So that's all you have to do to connect it up. Now, on the Osmose, you need to go in to your MIDI I/O global mode and go into DIN mode and set that to 5.5 CVC. One thing to be aware of is that if you set the CVC mode, the Osmose 1 port appears to become inactive. No output is sent on it. I don't know if that's a bug or by design, but right now, if you want to use the CVC and a USB port, you have to use the Osmose 2 Haken port. Once it's all connected up, what I suggest you do is bring up the editor. Now, there are some presets that Expressive E has created for the CVC. There's a 1 voice, a 2 voice, and a 4 voice preset in the utility category, but those are all programmed in the matrix. We'll talk about that a little later. If you want to use just a base CVC operation, your better option, and also you can do some things you can't in their programmed version, is to go in and just bring up an empty preset and set it for however many voices of polyphony you want to play on the CVC. You can see the CVC supports up to 4 channels of WXYZ outputs. For the Osmose, that's going to equate to a gate on W, 1 volt per octave pitch, for the most part, on X, your aftertouch on Y, and your pressure on Z. And you can set those various ways. You can also set this to different voltages, either through the editor with preset voltage options, or you can program voltage on it in the matrix as well. So if you only want to play monophonically, you can set your preset to only 1 voice and only 1 channel will come out. But if you set a preset to more than 4 voices, you're going to start dropping voices as it plays voice 5 and above, and you don't have it on the CVC. So if you're going to use the CVC, use a preset that's intended for it. Here I've set one up that's basically just the empty preset. It sets polyphony base 4, not expanded polyphony. That will give you more channels. Base 4, and I set priority low. But we'll set that right now to the same thing that the Osmose presets use, and that's priority oldest. Priority oldest will kind of cycle through your channels. So even though I have 4 voices set up here, you'll notice when the thing is on, you'll get a blue light in the middle, and when you play, you'll get some lights underneath each channel that'll tell you that channel's playing. So let me just cycle through. There you can see channel 3 came out. Now channel 2, channel 4, channel 3, channel 1, channel 2, 4, 1, 2. You can't really predict what channels are going to come out if you're going to use oldest priority. And I find that's not particularly useful on the Osmose if I'm playing polyphonically, or on the Continuum for that matter as well. So what I normally will do is set priority to lowest. Now what will happen is when I play a note, only the lowest channel that I'm playing will be played. So now, as long as I'm playing monophonically, only channel 1 is going to play. If I play 2 channels, 1 and 2 will play. If I play 3-note polyphony, 3 notes will play. 4 notes, 4. Okay? If I take one off, they basically play in the order I press my fingers, and so I can predictably now play my channels and know where they'll be sent on my modular. Now, if you want to know that this thing's connected, you see that it's not actually lighting up when you're playing. Go into the third control panel and you'll see a little CVC setup icon there. That'll let you do a number of things. Number 1, if you hover over it, you'll see whether you're connected. Here it tells me CVC, serial number 3290. So I know I'm connected. If it says not connected, you'll have to go debug. Normally, that'll mean either get out of the editor, get into the editor, repower the CVC, reboot your Osmose. One or more of those will normally reset yourself if you get yourself in a mode where you don't seem to be connecting. So now let's go through the default modes that you can get in the editor. If I click on CVC Setup, you'll see there are 7 default voltage options that have been predefined for various different kinds of modular devices and modular synths. One would be 10 volts, gate NN60 equals 0 volts. That's basically MIDI note 60 equals 0 notes and a 1 volt per octave output. Y, aftertouch equals 0 to 10 volts, Z equals 0 to 10 volts. And you have a lot of different options for connecting up to different things like Voyagers, Buchla, and other configurations that have a mix of 5 volts and 10 volts. Now, as we'll see, the CVC options that Expressive E provides you let you actually change your voltage internally in the program if you want to. A few other options are available here that might be useful. Normally on Z, on your pressure, the CVC will output, unless you program it differently, will output linear Z values. You can change that to use a square C value. A couple other options that might be useful. We can layer outputs. Now this doesn't seem to work too well with 2 channels, but if I set a preset to be monophonic base 1, and what this will do, you can see all 4 channels are now coming out when I'm playing monophonically, as if I have a mult going on. That could be useful. I can also go back to 4 voices and use one of these bass voice options. Bass voice 1 is what we've been using. Let me set bass voice 4. Now you'll see when I play, only the 4th channel's coming out. Even if I play polyphonically in my 4 voice setup, only the 4th voice will be playing. I can go in and set that, say, to bass voice 2. Now bass voice 2 will play as the bass voice. 3 and 4 will play. I can play more voices, but voice 1 will not play. This could be useful when you need to eliminate some voices in a setup, but probably now it's best when you want to do some customization like this to program it in the matrix itself using the CVC bank. Let's go through a simple use case of the CVC and the Osmose. Here I have a Synthesis Technology E370 quad morphing VCO. This allows me to play 4 voices at the same time. I've connected that up so that I'm not using any gates, because I want to use the pressure response of my Osmose in conjunction with a VCA to let the Osmose create a really sensitive modular performance. This is one of the things that it's really great for. So I'll connect up my 1 volt per octave pitch outputs of each of the 4 voices in red here to each of the 1 volt per octave inputs of the VCO. I'll connect up a Y output to one of the modulating inputs that I'll use to demonstrate that. Then I'll connect the 4 Z channels, the 4 pressure channels, to the CV inputs of my quad VCA. I'll send the outputs of each of the 4 voices as the inputs to the VCA, and that will in effect let me use my Z, my pressure, as the envelope. The output of the VCA I just send to a mixer. I could do something with that, send it through some kind of effects processor, but I want to keep things simple here. But this is one of the ways that I think is most effective to allow you to use your Osmose in the way that it was intended. Because you could connect up any CV keyboard and just gate away. So I've used just the standard CVC connection. I haven't programmed anything into the matrix yet. I've tuned up the oscillators, and I can play my 4 voices. I set each oscillator to a different timbre so you can kind of hear them. So I can play in 4 voices. My X pitch is active. How nice is that to impose that on a modular very simply. Now, the voices are set here as low priority. So as long as I keep the same voicing, I can kind of predict what channels are going to be sent to what devices. Now, if I keep one note held down and I move my other fingers, it doesn't necessarily mean those fingers are always going to play the same voice. They will follow the low priority. If I'd set this to oldest, things would be jumping all around. I couldn't predict anything. Now, let's turn up the modulation input on one of these lines that I have the aftertouch connected to, because right now aftertouch is doing nothing. So let me turn up that, and you'll see now on that first voice, this is only connected to the first voice. If I don't go into the aftertouch area, that modulation effect won't take effect, and it doesn't affect any of the other 3 voices. But the minute I go into the aftertouch, Y is active. Aftertouch can trigger some kind of a filter. Aftertouch might bring in some percussive effect. It's really wonderful. I can tell you right now, just the slightest press on a key will create voltage change. You might not even hear it in terms of what you're connected to in your modular, but if you set yourself up to a scope, the sensitivity of the Osmose connected to the CVC is just as sensitive as if you'd use the continuum. Now if I set it into polyphony 1, I can also get my pressure-weighted portamento working as well. So the CVC maps to pretty much everything the Osmose can do. The only thing to remember is the CVC follows what's going on in your preset. It's kind of Haken mode. It's not really following your external MIDI controls. Now, as a quick example, I've reset things here and I've removed Z. Instead, I'll just gate an envelope generator with my W gates. I'll feed the output of the envelope generator now into the VCA. I'm using this Zadar 4-channel envelope generator where I can set a different envelope to each one of the voices you can see. And so now when I play, I can have a more traditional envelope generator based performance. Now, that doesn't really make sense in the context of this 4-channel oscillator, but there's nothing to keep you from setting each one of the 4 channels of your CVC connected to a different module. So maybe some you'll use Z to do your envelope with, maybe some you'll use a gate and an envelope generator. You know, there's an infinite number of possibilities here. So I set things back in terms of the original CVC setup. And now let's talk about programming the CVC in the matrix. You'll notice that one of the banks, bank B, can be set to CVC custom control voltages. If this is already being used by something in your preset, you can also do the same thing on the bank C, but we'll use the standard bank B for this because we're not really going to be playing anything else for this example. You could in fact integrate the CVC into a preset that's playing something on the sound engine. Nothing to keep you from doing that. So let's take a look at what this means in terms of 1, 2, 3, 4, 5, 6, 7, 8 that you can program. I programmed the first 4 of these outputs with formulas A, B, C, and D. That will let me send out on the first CVC channel, and I can also program another set, maybe F, G, H, and I, on outputs 5, 6, 7, and 8. Well, how does this work? If you program only the first 4 outputs, and you play polyphony, and your preset is polyphony 1, you're only going to have W, X, Y, and Z outputs available from the first 4 channels. Now, if you set polyphony 2, and you play 2 voices, the formulas that you set for your first 4 channels will be duplicated for the second voice you're playing, and so forth. If you set your preset to 3-voice polyphony, those formulas will be duplicated on the third voice, and of course if you set 4-voice polyphony, those formulas will be duplicated on each of your 4 voices. Now, if you program both sets of outputs in the CVC, you really can only play 2-voice polyphony, but you can have independent formulas now going on each of the 2 voices. So if I'm playing only polyphony voice 1, I can still have 2 sets of formulas coming out. One set that will come out on channels 1, 2, 3, and 4, and the other set will come out on 5, 6, 7, 8. Even though you're playing polyphony 1, you can still have 2 separate sets of output channels using the 2 formulas. And if I set polyphony 2, well, now I will duplicate the formulas A, B, C, D on channels 1, 2, 3, 4, and 9, 10, 11, 12, and the formulas that are on 5, 6, 7, 8 for the second voice get duplicated on 13, 14, 15, and 16. Well, I have a simple formula here. 1 will be W, 2 will be X, 3 will be Y, aftertouch, and 4 will be Z, pressure. And if you have a formula on 5, 6, 7, 8, that'll duplicate. 5 will be W, 6 will be your pitch, 7 will be aftertouch, and 8 will be pressure. These formulas are going to map to voltages. You can program 0 to 10 volts, and what I've done here is I've gated A to 10. I've set my scaling to 10, I've gated W, so now when I gate on W, I'm going to get an instantaneous 10-volt gate. On B, which is pitch, I've set my standard X function min to max, but important here, I have to set octave mode, not kilohertz mode. Clicking in the middle, you can see I have result proportional to octaves or convert result to kilohertz. Well, kilohertz has no meaning in my CV world here. I need to convert this 1 volt per octave, so that's why I'm going to use my octave option here. Also note that you'll see a 0 point. That's what the little dot in the middle typically means, and this is saying the 0 point at which CVC voltage is 0 in its 1 volt per octave plus and minus voltage output is going to be C5. This maps to the standard X function that you'll use normally when you just type X into a formula. Now when I play, it's very similar to what I had before. So if I change the 0 point, say, to 3, I'm going to basically transpose up 2 octaves because the 0 point now has been taken down 2 octaves. And that could be useful if your octave scaling doesn't come out the way you want because you only have a certain limited number of keys on the Osmose. You can, with your CVC, change your octave here to put yourself in a range that you are most comfortable with or that you need for your modular setup. We'll take that back to its original setting. Now C is going to be aftertouch. I set this to go from 0 to 10 volts. If I turn up my Y that I had before, there I've imposed that modulation. You can hear Y coming in. If I take Y down to a smaller value now, you can hear that range of modulation is a lot less. So Y is going to be configurable to your needs here based on what you need to do voltage-wise. So Z is using the default nonlinear function squared going 0 to 10 volts as well. Let me turn the Y off. Now if I press very lightly, you can hear I'll crescendo to the aftertouch area. And then nothing in aftertouch. Well, you don't have to just use Z in these formulas. You can use any combination that you like. So we can do something similar to the last video where I might have Z only going to 5 volts, but I might have Y now going to 5 volts to get my 10 volt maximum. We'll take the shelving off as we did before. And now I can get the full crescendo through the key. And maybe for CV, this might make more sense to make linear as well. And that probably works a little better. Of course, with your VCAs, you can set linear and nonlinear configurations too, so you can play around with what you need here. So I think that gives you an idea of how you can program things. Let's go in and bring up the CVC 4 voice preset that you get with the Osmose system presets. This one's a little more complex. You can see it's actually playing the internal engine on oscillator 1 and sending CVC output. Well, I don't really want that output right now. I want to test the CVC, so I'll disable or remove the oscillator output, and now only the CVC is going to be active. That's higher than what I had before. It's also quieter. Why is that? Well, let's see what's going on here. For A, they gate 5 volts. Well, I don't really care about gate because I'm not using gate in this configuration. I'm doing everything with Z pressure through a VCA, so that one I'm not really concerned about. You'll notice there's a blend on this, that from the primary to the secondary, it goes from 5 to 10. Well, if we notice, there are 6 macro controllers used in this CVC output. This allows me to change my gate from 5 volts to 10 volts. In fact, that's used on Y. You can see that goes from 0 to 5 volts at the primary up to 0 to 10 volts on the secondary. And on Z, that goes 0 to 5 volts on the primary to 0 to 10 volts on the secondary. Well, let's go in now. Let's take off some of these other things that we'll talk about in a second. So now, if I want to do something similar to what I just did where I was going to 10 volt full scale, I'll take my 5 to 10 volt to maximum, and now I should have a higher volume because I'm putting out 10 volts and not 5 volts on Z. It's high now. Why is that? Well, let's see what they did with X. X, look at, they're using midpoint C3. So obviously they've transposed things up a couple octaves. I can go in if I want, make that C5, and it'll be similar to what we had before. So CVC can program with voltage values. You got to be careful there. If you don't set your scaling right, you could be very, very low and you won't get any sound at all. And don't worry about setting things for more than 10 volts because the CVC will limit output. This preset does a couple more things though. If you can see, it adds vibrato on my X with formula H. This is doing very much like what we saw in the last video. There's a little bit of sine shape generator modulation using shape generator 1. Here shape generator 1 uses a frequency of G. G is based on macrocontroller 3 for the rate of this vibrato. It's also scaled by Y plus Z. The shape generator is gated on W, and that's applied as a multiplier on the base frequency. If you watch our last video, we did something very similar. You'll notice that +1 has been added as an ancillary, so we don't multiply this by a very small number and get no sound because the frequency is too low. And they've also multiplied by 3 as well, so this 0.001 will actually turn into a 0.003 scaled by y plus z. But the bottom line is it's going to be a vibrato, the amount being the width of the vibrato set by controller 2 and the frequency of that vibrato set by controller 3. Let's give that a test. There's my tone, here's vibrato, but I haven't set the rate yet. There's my rate. Setting pretty quick. Let's set that about there. That'll work on all of the voices. So that's pretty cool, right? You can actually program vibrato into the CVC and it will take effect on whatever outputs you're sending X to. Of course, even on that vibrato, you can have your second order pitch bend effect imposed as well. Okay, so they did vibrato on X. Now, they put a couple other formulas, M and K, on Y and Z. We're not using Y that much, but let's see what's going on Z because they're similar formulas. So formula K uses another shape generator. This is set to controller 4. So this is imposing a triangle-based modulation on my pressure, which is scaled by Z, using this second shape generator, whose frequency is controlled by controller 6, also scaled Y plus Z. This is going to give me now more an LFO kind of a effect. We'll turn our vibrato off. Let's turn this pressure LFO on. You can see it's applied to pressure and also aftertouch with formula M, similar kind of formula. So if I bring the LFO width up and let me bring the LFO rate up, and you can hear this is more of a tremolo effect. It's a volume-based shape generator change, not frequency. And as I bring up the rate, that'll affect all voices as well. That gives you an idea of some of the programming you can do. Any formula that you use anywhere in the matrix can be used here. The only thing to remember is you are dealing with voltages, so you have to think in terms of the scale of the voltage you want to send out, as opposed to programming the sound engine where you're thinking on other scales. And to end, I've confirmed that the CVC does follow the pitch editor. So you can go to the Haken audio site, download the PTE, the pitch table editor, open that up in Max the way you do the Haken editor. If you're on Windows, you may want to close out the Haken editor first if there's going to be conflicts on connecting up to the Osmose device. And then you can use the pitch table editor to go in and create your own scales, to load some tables that have already been generated, or even load scales. As an example, let me go in, I'll load up a half step becomes quarter step table. That's realign things for quarter steps. I can go in now, select the MIDI 2 Osmose device. I'll use custom grid 80 of the tuning table options you can store in. I'll send that. Now let's play a scale. It's no longer set to equal temperament. hear that beating now? I'm playing in quarter tones on every semitone. And you can even do pitch bend on your quarter tones. How cool is that? I really haven't played around too much with this, but the pitch table editor is the means that you can use to do microtunings on your Osmose and experiment with other tuning systems. And it's all translated to the CVC that allows you to do microtuning on your modular.